Mars outward, as well as asteroids and comets. So stay tuned for a lot more to come.
Thank you so much, Nicole. Spectrum, and I'll be seeing you later on today. So we have 3 more big image reveals, and with that, new and more exciting science. But first, let's take a look back at the journey that brought us to this moment. Celebrations like this one are only possible with years of hard work from a cast of thousands. When a new mission is being built, even the most enthusiastic space fans only get to see dramatic moments in its life cycle, the news and images that come out in updates and press releases. But that doesn't really give you the sense of the huge effort that goes on behind the scenes every day. The plans, schedules, and organization to keep everything moving forward really happens, for the most part, out of people's gaze. Webb started as an idea that took root at NASA Goddard. It grew first into planning teams, research projects, schematics, requirements. Then it began the long journey to become real with the development of new technologies, cutting-edge engineering, and finally fabrication, putting it all together. Let's take a brief look back at the visionary journey to how we all got here today.
So today was the final closeout of the purge.
Okay, guys, I can hear Rupa,
It's
but
a pretty emotional moment to be in there and actually, closing it up for the very last time, right? You're the last one to touch this. And so that was the final operation. And once that fitting is closed out, there's no more touching of the vehicle. We're ready for launch.
The James Webb Space Telescope. Born from the desires of astronomers, achieved with newly invented technology, is the culmination of 20 years of work. Humanity has unlimited questions about our universe. Engineering a way to investigate them requires enormous creativity.
Webb has been a trade-off between engineering performance, what the astronomers want, risk. In fact, when we started 20 years ago, we were actually looking at an 8-meter telescope.
Developing the most sensitive instruments. And testing, and more testing.
And so you don't want to build one that's just incrementally better than what you've got. Because if that's the case, you would just observe longer on the telescope that you already got. And so every time NASA builds a new astrophysics mission, a new telescope, it needs to be way more sensitive, way more capable than anything we've ever built before.
We all got together in that conference room and we played real time as the images came down from the spacecraft. The very first diffraction limited images ever obtained with Webb, and what we collectively saw as a group was the highest resolution infrared image taken from space ever.
If you're just joining us, I'm Michelle Fowler at NASA's Goddard Space Flight Center, and you are watching live coverage of the release of the first science images from the James Webb Space Telescope. So it's appropriate now that I send the broadcast to our colleagues and friends at the Space Telescope Science Institute in Baltimore. That's the scientific nerd center of the entire Webb mission. So hello, good morning, Alex. The show is yours.
Hey, Michelle. Welcome to the Space Telescope Science Institute. I'm Alex Lockwood, and I'm here with Carl Gordon, who is an astronomer and one of the key people in delivering the images that you're going to see here today. But actually, before we get into the amazing images, we're going to talk a little bit about where we are. We're sitting here outside of the Mission Operations Center, which is the key central hub for Webb. For the past 6 months, scientists and engineers have been working 24/7 since they took control of the telescope 30 minutes after launch to prepare for today.